All right, so we've written a code that will deal with a ball that has constant velocity. If we want our velocity to change, then we're going to have to update the velocity inside the loop. So right after this line where we update the position of the ball, I'm going to add a line that updates the velocity. It says the velocity is equal to the initial velocity plus an acceleration times the delta t, time step. Put a little space in here to line up. So this is update the velocity of the ball. Now, since I'm updating the velocity inside the loop, I can't specify it every time. That would just rewrite the velocity and overwrite it every time. So I'm going to take this initial condition and bring it outside so that it becomes a specification of the initial velocity of the ball. I can set that to whatever I like. Okay, so then inside the loop, the initial velocity is set, the time scale is set, the ball's position will update according to the velocity, and then the velocity will update according to the acceleration. I see I missed that there. We also need to define then what the acceleration of the ball is going to be. So in our physics, the acceleration is due to a force. We'll start with just the force of gravity in this case. So the force of gravity is going to be m times g. So m will be the mass. We'll define that in a minute. G is 9.8. That's a constant, so I can set that in there. And the force needs to be a vector. The force of gravity will be downwards, and the vector that represents that is 0, minus 1, 0. Then we can set the net force equal to the force of gravity. I know that looks a little silly, but if we add other forces later, that'll be a really handy line to have. And then the acceleration is just given by the net force, whatever that may be, divided by the mass. That's Newton's second law. So up here, this is the part of the code that tells us that the force results in an acceleration. And down here, once we found the acceleration, this is where kinematics happens. All right, let's see. I think we're almost ready, but if we run, we might find an error. So we have not yet defined the mass of the ball, and that's the important part of our calculation now. So back in here, that would be something that would be appropriate to set in the initial conditions. And I'm just going to set it equal to 1 right now. Set the, oh my goodness, set the mass of the ball. All right, let's see what happens. Okay, we have gravity working. It's pretty quick and it drops the ball right out of the frame. I'm going to scoot the ball over to a little earlier place in the frame, so I'm going to go to -5 in the x dimension just to position it a little more to the left. And I think I will need a little bit more upward velocity and a little bit more rightward velocity. That was rightward and upward. And now let's see what happens. Beautiful. Okay, so we have a projectile that's behaving as we like.